Okay, so we're all starting at page 11, the top problem, example 4. And the reason I'm doing this is because it's a continuity of what we have just done. The only difference is, do you notice that they haven't given us a polynomial?
Actually, make a polynomial.
You have to create your polynomial. So it says the first step is write a polynomial. So we are on page 11 for anyone who's looking for the stuff. Yeah, we are on page 11. Okay, so it says write a polynomial. Unlike the previous problem where the polynomial was given to us, I have to write the polynomial in the factored form because that's what helps me in graphing. And using the given information, we have to write it, and then we will sketch it. We will sketch it. So let's go ahead and take a look at what we have to do to create a polynomial. Whenever you have to create a polynomial, f of x, you need to know the factors. You need to know the factors. And so let's see if the factors are basically created by the zeros. So zeros is the one that helps us to create the factors. So what are my factors going to be? I will also keep in mind I can write my factors, but I don't know my leading coefficient is positive or negative and what the value is. So for now we will leave the leading coefficient as blank. We will call that a. So remember, a is the alphabet that's used normally for the leading coefficient, a x square. You know, that's the leading thing. So for now we'll leave a as a. We have to actually calculate for a, because whether it is positive or negative will determine when I start graphing whether it needs to, what the end behavior is going to be. My zeros are, what are my two zeros? Negative, there are only two zeros, negative 1 and positive 3. Negative 1 has a multiplicity of 2. So what if my 0 is negative 1, what is my factor? Perfect, good answer. Everybody agrees? It's x plus 1. And multiplicity of 2 basically means squared, exactly, it is squared. And my next 0 is positive 3. That means my factor is x minus 3. If they don't give you any multiplicity, it's just raised to the power of 1. So I pretty much have the information to be able to graph sort of, in the sense that I do have my x-intercepts. But I cannot do anything without knowing. I know my degree to be. Degree is 3. They tell you the degree is 3, but I don't even need to know because I can just add this up. So I know my degree is 3. Except, so it's going to behave like a linear. It's going to behave like a linear because of degree 3, but I don't know if my leading coefficient is positive or negative. Without that, I will not be able to find out. Okay, John, yeah.
What is P1?
Okay, that's what we are going to get to. That's exactly what we're going to get to. Okay. So for me to solve for A, what they do is they give you 1 point. That is this point. This is actually a point on your graph. P1, it's like your f of x, equals to negative 4 basically means that my x is 1, my y is P, f of x equals to whatever value, my y is negative 4. So it is a point on the graph. I'm sorry, you can't see. This is a point on the graph. P stands for a point, so it's a point on the graph. It's a point on the graph. Using this point on the graph, can someone tell me, will this help me solve for A? Because once I solve for A, I will be able to graph. I have Leah's hand up, yes. You have Tim's hand up. Okay, Tim, go for it.
So you plug in the output you get, which is negative 4, and my f vector is
Perfect, good answer. Was that your answer, Tulia? Yes, perfect. That's absolutely. So you basically, this is your x, this is your y. I substitute for my x to be 1. I substitute my y to be negative 4. The only thing that's left in my equation is A. The x is substituted, y is substituted. Remember, you can solve any equation as long as there's only one variable. So that's what you're going to do. You're going to substitute 1 comma negative 4 in this equation. You're going to substitute 1 comma negative 4 in this entire equation, not just here, entire equation. So this is your x, this is your y. So negative 4 equals A. A is your only unknown. X is 1. So 1 plus 1 square, 1 minus 3 square.
It's not square.
It's not square? Oh, I'm sorry. You're right. Thank you. Okay, we can all do, this is just PEMDAS. You just have to make sure you're doing the order correctly. First you take care of the exponents. First you take care of first you take care of what's in the parentheses. Then you square it or do whatever, and then get a by itself. Tell me what you get for a. You should all be able to do this without my help. Did everybody get this? And please ask me if your answer is different, or because remember I make mistakes too. So this is my work, and I got a to b half. So now I'm all set, right? I don't need any more information for polynomial. I have my polynomial now. Once you have a polynomial, you all of you have the skills to graph it. So my polynomial is f of x equals positive half x plus 1 square and x minus 3. So this is my polynomial.
Can we say dx?
Yeah, ideally, but that's okay. Yeah, ideally, yes. Okay, now that you know how to graph a polynomial, go ahead and do these 3 steps. You're going to do these 3 steps. First, find the end behavior. You know the degree to be third degree with a positive coefficient. So third degree with a positive coefficient. That means it's going to behave like a positive slope, linear, positive linear graph. So it will start in this and end in this. So that's your step number 1. Step number 2, your x-intercepts. And step number 3, y-intercept. Okay, do all of these. Finish graphing. Everybody got y-intercept as negative 3 over 2? Yes? Okay, now go ahead and sketch it. Yes. Did everybody do okay with this? Yes, yeah,
How
yeah.
did the 1/2 influence the graph?
Because positive. The only thing is positive.
Okay.
Okay, no, actually, I should take my word back. It's positive, so you know it's third degree positive, so you're climbing up the hill. Second is it helps you calculate the y-intercept. Without that, you won't have the exact y-intercept.
Okay.
Yeah.
And then should you involve the 1 negative 4 point